All right, so yesterday and last week we talked about graphing quadratics in factored form or intercept form. Today we're going to get into graphing quadratics in standard form when a is 1. Okay, so first we have a new vocabulary word. Actually, it's not new, it's just a reminder. And it's standard form. Standard form is when you have a quadratic written in y equals ax squared plus bx plus c form. That's what we call standard form. We could also, instead of y, we could have f of x. And that would be the same as just writing y. Okay, so if we're going to go through some steps on how we should be working through graphing quadratics in standard form, step 1 would be to factor the polynomial that you're given. And to look for any greatest common factors first. Make sure you can't factor anything out of every term. Step 2 is to identify if the parabola opens up or down. This is just so that when you get all done graphing, you can go back and check and make sure that your parabola is facing the right way. Next, we'll plot the x-intercept since it's in factored form. Now, step 4, locate and identify the axis of symmetry. Which we know is just the average of those two intercepts. Define the x-coordinate. And then step 5, calculate the vertex point. And you'll see vertex represented as v and then your two coordinates. And the way that you find those is the average of your x-intercepts. This is just a reminder. And then you plug that number in to solve for y. Okay, last step is to use a table of values. And a reflection of those points across your axis of symmetry. Okay, so let's jump in and start our first example. I know mine's kind of small here, so just follow along in your notes. First up is f of x equals x squared minus 6x plus 8. Okay, first thing we have to do is write this in factored form because we don't know how to graph that as is. So I'll just factor 2 parentheses. I know x times x is one way to get x squared. And if I have opposite signs, I know these are both going to be negative because a negative times a negative is a positive. Okay, 4 times 2 is 8, and negative 4 plus negative 2 is negative 6. Okay, so I've got it factored. Notice today we're working with a equals 1. So this number in front of everything is going to be 1, and it's positive. If that's positive, that means that our parabola is going to open up. The solutions, remember we solve by setting the factored form equal to 0, and we'll get 4 and 2. Those are the roots, solutions, x-intercepts, and zeros. Okay, so then the axis of symmetry is going to be right between 4 and 2. We don't really even need to add them and divide by 2. The only number between 4 and 2 is 3. Okay, and from there we're going to find our vertex point, which I'm going to get you in the habit of writing v in front of that point. We know the x-coordinate is 3. We get that from the axis of symmetry. And we need to solve for the y-coordinate. So we know that y is going to equal 3 minus 4 just plugging x into our factored form. 3 minus 4 times 3 minus 2. 3 minus 4 is negative 1 times 3 minus 2 is also negative 1. Oh, sorry, is positive 1. So your y-coordinate is going to be negative 1. Okay, so let's graph some points here. The point at 4, a point at 2. Axis of symmetry is right at 3. My vertex is at 3, negative 1. All right. We know we need to find our y-intercept yet, so let's plug in 0 for x and solve for y. Y will equal negative 4, which I'm getting from your factored form, times negative 2, which is positive 8. So I'm going to graph my point at 0, 8, and there's my y-intercept. So I'm going to go ahead and write 8 down here for my y-intercept. Okay, now let's graph the reflection. This point reflected over the the axis of symmetry. It is 1, 2, 3 away. 1, 2, 3 away on the other side. And the height's going to be the same. So this point is at 6, 8. All right, and I like you to graph at least 7 points if we can. So let's go ahead and find a point at x equals 5. When x is 5, we're going to have 5 minus 4, which is 1, times 5 minus 2, which is 3. And I'll get 3, y-coordinate 3. So go ahead and graph 5, 3. Okay, and I know my next point is going to be the same height. I just have to find the x coordinate. It's 2 away from my axis of symmetry, so I'm going to go 2 away on the other side, and I see that it's at 1, 3. Okay, from here I can draw a lovely parabola, a nice smooth curve, and we're done with our first example. All right, I'm just going to look ahead here and see how many examples I'm going to do. Let's do example 2 for sure. Okay, so we have an equation, a quadratic equation written in standard form. I need to write it in factored form. So I'm just going to go ahead and factor what I've given you here. Draw my parentheses, write my 2 x's. Okay, middle sign is positive, last sign is negative, so I know I'm going to have opposite signs. I'll just do a minus and a plus. 3 and 5 give me 15, and I can figure out a way to get those to add to 2. The bigger number has to be positive, so 5 is going to go here, and 3 is going to go here. Once again, this one opens upwards because I have a equal to 1. And my roots are when I solve for when y is 0, and I get negative 5 and 3. Okay, axis of symmetry. Let's find the average of those 2 points. Negative 5 plus 3 divided by 2. That's going to give us axis of symmetry at negative 1. Okay, 1, 2, 3, 4, 5. I'm going to graph the points that I have now. 1, 2, 3. And my axis of symmetry is here at negative 1. Okay, vertex point. We know the x-coordinate is going to be negative 1. What is my y-coordinate going to be? Well, when I plug in negative 1 to the equation, I'm going to get a large negative number. Let's see, negative 1 minus 3 times negative 1 plus 5. This equals negative 4 times 4, which is negative 16. Plug that value into my vertex point. Okay, I'm going to have to change my scale here, and that's fine. Let's go down by 2's. Negative 14, negative 16, negative 18, and negative 20, and up by 2's on the opposite side. Okay, so I'm at -1, -16, and there we go. Of course, since I've only changed one scale, my graph is going to look wider than it actually is. I would have to change the scale to get an accurate picture. So I'm actually going to go ahead and do that so this doesn't look... No, I'm not. We'll just realize that this graph is going to be wider than, or wider because of the scale. There we go. Okay, so time to plug in some points and graph the rest of this parabola. I know I'm going to need to solve for my y-intercept down here, so I'm going to plug in x equals 0. When x is 0, y is 0 minus 3 is -3, 0 plus 5 is 5, y is -15. And I'm going to go ahead and write down -15 because I know I'm going to have 2 points of that same value, same y value. Okay, so 0, I'm going to go halfway between 14 and 16, and there's another one at -2. Okay, let's go ahead and try 2. When x is 2, y will be, 2 minus 3 is going to give us a -1 times 2 plus 5 is 7. This leaves us with a y value of -7. I know I'm going to have 2 of those, so I'm going to go ahead and graph this one, and 1, 2 away, 3 away, 1, 2, 3 away on the other side, brings us to -4. All right, that's my 7 points. I'm going to go ahead and graph my parabola. And right, my y-intercept is from this very first point, it is -15. Okay, let's do one more. This is example 3 in your notes on page, should be 19. So same drill. You can go ahead and pause me and try and factor and solve, fill in all these blanks on your own. And start me back up after you've done that. Okay, so let's solve this one in factored form. You should have already factored. And we're going to get f of x equals x minus 2, x minus 1. I'm going to go a little faster now since you've already done it. This one has a positive a, just like all of yours today should. So it's going to open upwards. My x-intercepts, I'm solving for when y is 0, and I get 2 and 1. Remember, it's the opposite of whatever you have in your factored form. Okay, my axis of symmetry. If I average out 2 plus 1 and divide by 2, I'm going to get 1.5 or 3/2, however you want to write that. So plugging in for my vertex point, I'll get x equals 1.5. I'm going to go through this quickly now because you've already done it. X equals 1.5, and when I plug in for x in my equation, I'll find my y coordinate. 1.5 minus 2 is going to be -1/2 times 1.5 minus 1 is +1/2. -1/2 times +1/2 is going to give me a -0.25. So that's the value I'm going to plug in here. There we go. Okay, I'm going to have to be kind of careful graphing these. So let's write in our x-intercepts right now. 1 at 1, 1 at 2. I'm just going to lightly draw in my axis of symmetry. Okay, I know my vertex point is going to lie on the axis of symmetry, and it's at 1.5 and -1/4, which is barely underneath there. Okay, when I plug in 0 for x to find my y-intercept, I get y equals -2 times -1, which is 2. So my y-intercept I can write down right now is 2. So I'm going to go 0 up 2, 1.5 away, 1/2 and 1.5, and I'm at 3, 2. All right, I need 2 more points. I'm going to pick let's see, 4. When I plug in 4 for x, I get 2 times 3, which is 6 for y. I know I'm going to have one more point there at 6. I'm just going to make sure that's separate from my table. Okay, so let's graph 4, 6. 4 up at 6, and we're 1, 2.5 way, half, 1.5, 2.5. So I have another point at -1, 6. All right, I'm ready to go graph my parabola. Nice smooth curve. And there we are, example 3, all finished. Hopefully you got it all right. You can go ahead now and start worksheet 7.5. You're going to do all except for, I believe I crossed off number 4, but you can check with the sub. All right.